Thank you for introduction, and thank you for your huge interest in big data and prototyping in particular. So our agenda today is pretty short one. It's about big data and prototyping, and then you will learn everything from next slides. So you may heard about big data systems and their capabilities, like processing terabytes or petabytes of data, doing real-time analysis and other magical stuff. But what is the main difference between big data and traditional systems, like small data, if you will? And if you look at that diagram, you may notice that there is a central place which is basically implemented by a relational database. So in most cases, this is RDBMS, right? And with help of ETL and with help of lab cubes, it was a silver bullet for a long period of time. And nowadays, if we look at a big data system, we may notice that there is no longer one solution which fits all problems. So it's a tutti-frutti approach, if you will. And it means that you need to combine multiple technologies and techniques to satisfy pretty complex system and business requirements nowadays in big data. These are MPP data warehouses, Hadoop, NoSQL, in-memory analytics, and so on and so on. And there is no doubt that it introduced additional challenges. So 5 of them are 5 V's: volume, variety, velocity, veracity, and value, right? You may heard about 3V, 4V, or 5 V's, as in this example. And these are big data requirements dimensions. So actually, every system has a unique combination of these V's, and every system has a unique success criteria. The paradigm shift needs to be taken into account by architects and big data engineers. So it means that instead of only relational modeling, these guys should know data lake concepts, polyglot persistence, or knowledge of multiple NoSQL databases, Lambda architecture, and so on and so on. The short history of big data system development introduces new challenges. So it means that there is no single guideline, or there is no a single standard how to implement big data solutions. And rapid technology changes means that pretty often marketing of technological companies is far ahead from technology capabilities, and you need to test it. And of course, having 100 or hundreds of available options makes the selection of big data technology is extremely complex, especially if it's first time. And as we may see, all this complexity leads us to necessity of creation of prototype, because obviously just analysis, architectural analysis, cannot solve all these problems. And what are typical signs of prototype, or of the need for prototypes? So these are, just briefly, requirements are uncertain, technologies are new, no comparable system has been previously developed, no full buy-in from the business. So all of them leads to a need to create a prototype to make sure that you are in budget and in time. So we distinguish 4 types of prototypes. One of them is horizontal prototype, and that one is more about user interface. So actually, it's the goal of that prototype is to explore functionality of your system, is to explore scope of your system, to understand it better, and to provide mockups or wireframes to your users, end users, to check early feedback. Vertical evolutionary prototype is a great tool to mitigate technology risks, especially integrating technologies. So it can serve as a skeleton, and it can integrate components or technologies into one integrated stack. Throwaway prototype or a proof of concept. It's often misunderstood by big data community or just software community in general. Sometimes many developers and architects refer this term to any prototype. But actually, this is about throwaway or rapid prototyping. And in many cases, it's about testing one component in a particular scenario, let's say in performance or in scalability. So just one scenario, quality attribute scenario. And minimum viable product, or MVP, is rather a business decision than a technological one. And it helps you to get early feedback from users, from end clients. And it helps you to achieve some business goals. For example, presenting your first working version at a trade show. So you just seen 4 types of prototypes, and you may think when to introduce them in your project lifecycle. And this is just a common sense. If you like recommendation from us, start with initial architecture analysis, surprisingly. So it helps you to create architecture design and to select candidate technologies. You may then return to this consideration and choose another one. But anyway, you need to start from something. So you pick candidate technologies. Rapid horizontal prototype helps you to create a set of mockups or wireframes and actually explore functionalities of your system. Just get quick feedback from your users. Vertical evolutionary prototype is, so you can start it in any project, not necessarily big data. So this is best practice that works in any complex project. So it helps you to integrate selected components, and it helps you to mitigate major technological risks. And proof of concepts, you may see that they are part of vertical evolutionary prototypes. So these are just spikes, and you can use them to mitigate a particular technology risks. So let's say one component which you are not sure that supports required performance or scalability. And for that reason, you can do that spike and dedicate some efforts to test it. And all of these scenarios lead to MVP, which is your first version of production system. Rick will explain in more details the criteria, if you will, for deciding whether to go with a prototype or to stay at analysis phase. And you can find more details in our paper, which is just recently published by IEEE Software Magazine. Rick.
Okay, thanks, Serhiy. Okay, so now I'm going to describe the RASP model. And RASP stands for Risk-Based Architecture Strategic Prototyping. And although the title of this presentation is Strategic Prototyping for Big Data Systems, as Serhiy said, there's really nothing special about big data systems in our process that we've defined in this way of thinking about and approaching the problem. If you were doing any kind of domain where there's lots of evolution in the tools, where your requirements are uncertain, if you're doing smart grid, or you're doing Internet of Things, or any kind of complex, rapidly evolving domain, you want to think about how you're going to manage risk and how you're going to do prototyping to help you gain understanding. And this model, the RASP model, which I'll show you momentarily, can stand alone, but we think you should pair it with some form of design model. So we're going to show you a design model called big data design very quickly. That's not the subject of this presentation, but big data design, BDD, is an adaptation of ADD, of course, so attribute-driven design, but specifically for the needs of designing big data systems. So in BDD, there's a value discovery phase where you're looking for business value, business goals, then a requirements analysis phase where you're looking at scenarios and what kind of innovation you're looking for, and you're enumerating your architectural concerns and constraints. And then you go into a design loop, which looks very much like ADD, except that you've got some additional considerations, such as a data flow diagram, or figuring out what your metadata is going to look like, that are specific to doing a big data project. But essentially, this is an architecture design method. And then finally, you move to implementation testing and evaluation. The RASP model coincides with each of those major phases of value discovery, requirement analysis, design, and so forth. So in RASP, there's these two parallel streams of architecture analysis and strategic prototyping. And the idea is that you have to choose which of these techniques you want to use when, and in fact, figure out how they dovetail together. I would prefer, all other things being equal, to just do architecture analysis because it's less expensive. On the other hand, there are risks that architecture analysis alone cannot address, and at those times I need to move over to this right-hand column and do prototyping. So I can analyze the risks in the business goals, in business alignment, in my strategy. I can analyze the risks of missing or ambiguous or conflicting requirements. I can analyze the risks in the architecture decisions that have been made or not made, and also for the risks in terms of evolution. So I can analyze all of those from an architectural perspective, but when this proves not enough to address the risks, or not to address the risks at sufficient detail with sufficient granularity, then I can move over and do prototyping, as Serge was just talking about. Throwaway prototypes, evolutionary prototypes, and eventually an MVP. So this is the RASP model, and we just present it as a flowchart. It's essentially a series of questions that you ask yourself and decisions that you make based on the answers of those questions that lead you to one of those techniques or another. So initially, we believe you should always start with architecture analysis because it is, relatively speaking, inexpensive. And so first thing you can ask yourself is this a greenfield system? If it's not a greenfield system, then you need to look at what are the new requirements. We're now evolving an existing system. What are the new requirements, and are there risks that those requirements imply? And if so, we want to do an architecture analysis, update the architecture, select technologies. Fine. If it's a greenfield system, again, we want to perform an architecture analysis, select a reference architecture, in this case, because it's greenfield, and candidate technologies. And then we move over to this part of the RASP flowchart, where we ask ourselves, for each selected technology, is there a significant risk? Is this something that we don't have experience with, or we've got perhaps a new usage of a technology that we've used before and we don't know how it will perform with this kind of data, this scale of data, with these extremely low latency requirements, or so forth. So if that's the case, we've got a procedure call, right? Go to the throwaway prototyping chart. That's next. If not, then go ahead and do your business. Integrate the technologies, test your functionality, test your quality attribute scenarios. Did you discover any risks in that? If so, reconsider technology selection and iterate. If not, you're done. So if we ended up here, that there's a risk with a specific technology, then we go to the throwaway prototyping part of the flowchart. So is this a new technology? It's not a new technology. Are there any new requirements? There's no new requirements. We're done. Good. Maybe it's a new technology, but it's been used before by you or perhaps by someone else. Perhaps there are benchmarks, there are experience reports, published studies, and so forth that have proven the technology for your scenarios. And if you, of course, proven is in quotes, you would have to trust that the organization that provided that evidence. But if the answer to either of those questions is yes, you're done, right? Somebody says, yes, use this for your usage scenario, it's going to be fine. If the answer is no and no, now you're in the land of creating a throwaway prototype, in which case you're going to have to describe the usage scenarios, let's say the characteristics of the data volume, the latency requirements, the stability requirements, scalability requirements. And now you ask yourself, well, does the prototype that we've built, this quick and dirty throwaway prototype, does it meet those requirements? Yes, great, we're done. No, oops. What do we do? Well, perhaps there are more configurations, more models. We can try scaling this solution up, putting it on our cloud, assigning more VMs to it, parallelizing the data more. So more configurations we can try, iterate. If not, we've exhausted those possibilities, go back to the customer. Is it possible to soften any of the requirements? Do you really need 20 millisecond latency? Wouldn't 100 be okay for your situation? If they say yes, again, we're in happy land. If not, you better go back and rethink your technology selection. So that's the RASP model. It's just a way of structuring the decision process and figuring out when we do cheap things like architecture analysis and when we are forced to do more expensive things like creating prototypes. So we validated this model in 9 big data systems, 9 case studies. These were quite diverse domains. So there was intrusion prevention network security system, a coupon web analytics site, a cloud-based mobile app platform, and so forth. And these systems had quite diverse big data requirements, enormous data volumes, in some cases very short data latency. You can imagine an intrusion detection and prevention system has to respond very quickly to detect and respond to a threat. And in addition to the paper that Serhiy mentioned, published in IEEE Software, we've published all of the data on our case studies at this website. So what did we learn? We've tried to summarize our experience in terms of 7 guidelines. Architecture analysis might be your only feasible option if you need to make early decisions. If you have to commit, and you have to commit early, it's better to do architecture analysis than to just run to implementation. But architecture analysis, we recognize, is insufficient alone to prove many important system properties, particularly if you are in a fast-changing domain. If you're building an e-commerce 3-tier client-server system and you've built 14 of them before, you're probably okay. And a little bit of architecture analysis, and you say, is this system kind of similar to what we've built before? Yes, check, move on. But in the big data arena, that's frequently not the case. The requirements are idiosyncratic. The tools there's a broad range of tools, and they're changing all the time. The landscape is changing all the time. And so we recommend complementing architecture analyses with vertical evolutionary prototyping, because you can implement this as a skeleton and gradually add additional functionality, assuming your prototyping results leave you in an acceptable range. You can gradually grow this into a full-fledged system, fleshing out that skeleton, that architectural framework that you've created with your design method. Whoops, what happened? In addition to the vertical evolutionary prototyping, you may need to do throwaway prototyping for selected technologies. Again, this is a large landscape, and no one technology is going to serve in the big data domain, and so there will likely be questions about specific technologies, and a throwaway prototype is a good way to help you evaluate a technology to see if it's sufficient in your context for your use cases and your quality attribute requirements. As Serge mentioned, MVP is more of a business decision. This is a way of getting something in front of the user quickly. Typically with an MVP, you want to instrument it, and you want to conceive an MVP as an experiment. Whenever you're fielding an MVP, you should have some measures that you've already defined that you're trying to collect. And the purpose of the MVP, in addition to getting feedback from the customer, is to collect measures about the use of that product in a real context so that you can then make further decisions. So that's our talk. Just to summarize, risk analysis is obviously necessary for controlling the design process, for the evolutionary design process. And what we've seen in our case studies and our experience is that by marrying an architecture design methodology to a risk analysis methodology, we can manage risk, project risk, we can manage cost, and we can manage schedule much more effectively. This gives you a basis for thinking about value discovery with stakeholders, for thinking about risks, for estimating cost and schedule, getting quick feedback about how easy or hard something's going to be, how expensive it's going to be, and for supporting a process, a scientific process of experimentation. So that's our RASP model. That gives you guidelines for how to do that and structures your decision process. So with that, we've got 5 minutes for questions. Thank you.
Please make questions, and please repeat the questions so that we can hear.
Okay, so first.
So in the industries that you worked in, how did you estimate the time you need to do that RASP model? And again, like I think all else being equal, one question that always comes up is, all right, Mr. Architect or the architecture team, how long do you need for you to do this work, right?
Okay, so the question is, how long does it take? How do we estimate how long it's going to take to actually do the RASP model? So I'll let you answer.
So that's a great question, and our customers ask all the time. So what is the estimate for your prototype? And usually we suggest the following model. We start with architecture analysis, and we call it discovery phase. It can be relatively short. It can be a couple of weeks. So it depends on project complexity. And after that, we provide with estimates on a larger phase, on a proof of concept or on the MVP version of that system. So actually, we include those types of prototypes which are necessary for success of that system. So it goes as a separate estimate, because we already have that knowledge from initial architecture analysis. And then, after that stage, we can provide a final or finest estimate for that whole implementation cycle. So, like 3 iterations, if you will. And if that customer have patience, the success of or the probability of success is highly increasing. If there is a time pressure, then it's a pressure on us, it's a pressure on that customer, and it may lead to consequences. So we educate our customers to follow that 3 phases approach, if you will.
Yeah, and that's one of the reasons why we present this as a risk-based methodology, that our emphasis all the time is how do we measure, manage, and control risk. So, question?
My question was about how would you then, once you've got your architecture, you've got your product, but you're looking more along the terms of agile development, how can you apply the RASP model to evolutionary architecture, so where you're having to evolve along with the landscape on top of that? How
Sure.
does that work?
So the question is, how do we apply the RASP model when we're now in maintenance, evolution, and we're doing an agile life cycle? So our approach is that we see these prototyping activities as being aligned with spikes in an agile project. So you would typically, fork off of your main development branch. When you have a technology question, you would do a spike, in a time-boxed, relatively short time, 3 weeks or 2 weeks or 6 weeks or whatever is appropriate. And then based on the results of that, you would dovetail that back into the main branch. You want to add anything?
Yeah, absolutely. So if we even look at that quick model, so here we go. So let's consider, for example, that this is already created product, for example, and it's in evolutionary state. So in this regard, these, yeah,
Fast throwaways.
yeah, absolutely.
Okay, thank you.
Any additional further question? Last question?
Well, the MVPs, well, my organization, that we don't have time to visit those POCs with the new one, right? So I try to see the MVPs sometimes a way to put runway items for implement the larger architecture, not just a pure prototype, right? So as a part of what will end up being your architecture.
So you're saying you use your MVP as a runway, okay. Okay.
Sometimes, at least, I don't have time or resources to invest in actually just do a throwaway, right? So I try to use those as something like that. Probably that.
Okay, so the comment was that in his organization, they use the MVP as a runway essentially to test, to prototype, and evaluate new technologies. I guess the only risk there is if you've chosen wrong. And that's where the throwaway prototype is one of these fail-fast strategies, right? With relatively low cost and relatively low risk, you've figured out yes or no, is this technology going to work, and it's not on the main branch.
And if it works, actually, it's a real MVP because it's
If it works, then you guessed right, and you're the hero.